What's up, everyone, and welcome. Today I want to talk to you about the Codecov supply chain hack, specifically about the Bash Uploader dev tool that was compromised. I came across this article on securityweek.com back on April 15th, and every day there's been some new information that's come out. The original article that I read here on the screen is from Ryan Narain. It's a great article filled with information, but it didn't tell me everything that I felt I needed to know, so I did some more digging and found out more information really about the scope of it, the depth of it, and I have some recommendations of how you can protect yourself, protect your code, protect your clients, as well as improve your processes to ensure that this kind of thing doesn't happen to you.
Listen to me, boy. Pay attention when I'm talking to you.
So let's jump right into what we know so far. On April 1st, 2021, Codecov was contacted by a client and made aware that there was a problem with their software. How did the client come up with it? The client downloaded the software and did a checksum. They basically compared the checksum that's provided with the software on GitHub with their own locally calculated checksum and saw that there was a discrepancy. They didn't match. They weren't identical. So that means that the software that this client downloaded was not the same software. It was modified software than what the developer, in this case Codecov, had intended, had uploaded. So they did a forensic investigation, and it determined that the attacks began in late January. They say that it was through the use of an unauthorized access of a Google Cloud storage key, and then they go on to say that their Docker image build process was where the hole was. It's been patched. That's the good thing, but we have to look into exactly what the ramifications are. So it's 3 pieces of software. Right? They call it the Bash Uploader tool, but the Bash Uploader tool is included in 3 specific pieces of software. One is called the Codecov Actions Uploader for GitHub. One is the Codecov Circle CI Orb, and the other is the Codecov Bitrise Step. And all 3 of these softwares have this uploader tool to basically transmit data from specific repos or data stores through to Codecov to make to help make code coverage reports. According to Codecov, the altered version of the Bash Uploader script could potentially affect 3 areas. The first is any credentials, tokens, or keys that customers pass through their CI runner and would be accessible when executing this Bash Uploader script. So if you have a private repo internally in your inside your network, or if you have it hosted on GitHub as a private or GitLab or somewhere, and that's using the Bash Uploader tool, then the hacker has access to your tokens, your keys, and your credentials. The second area is services, data stores, and applications. Basically, the Bash Uploader tool has to connect to something to get the data. What it's connecting to, because the hacker now has those credentials, what it's connecting to, the hacker now also has access to what it's connecting to. The third is, they say it's the Git repo. Well, if the Git repo is what the Bash Uploader script is connecting to in order to grab that code coverage report data, then they have access to your repo as well. So, officially, the chief executive, Gerard Engelberg, said the company has rotated all relevant internal credentials, including the key used to facilitate modification of the Bash Uploader. So they fixed the problem. But let's take a quick look at exactly how it was found out, and what the tool does to see whether or not it affects you, and how they did it more in depth, and then what you could do to protect yourself. So again, one of the clients downloaded the tool and did a checksum. Well, what is a checksum? So the official definition of a checksum is it's a sequence of numbers and letters used to check data for errors. If you know the checksum of the original file, you can use a checksum utility to confirm your copy is identical. So again, you're given a checksum value when you go to download a piece of software. You download it locally. You use a utility to perform another checksum or a comparison, and to see whether or not they are identical. If they're not identical, then that means that the code that you have just downloaded is not what the developer uploaded. They're not the same. There's been changes within the supply chain. So the client performed this checksum, found that there's a discrepancy, talked to the company. So what is actually the upload, the Bash Uploader script? What does it do? If you go to Codecov, you see that the official definition for the Codecov Bash Uploader is it says that it provides a language agnostic alternative for sending your coverage reports to Codecov. So there are different ways to send your reports to Codecov, or to get your reports into Codecov, and one of them happens to be through this automated Bash Uploader script. The main objectives of the uploader are to detect the environment, gather reports, and upload them to Codecov. So in order to do this, in order for it to work, the Codecov system requires certain sensitive secrets like tokens, keys, and credentials. And that's what we were talking about within those three areas of being affected. So this automated uploader tool takes your credentials, either stored locally on a system or passed through in some type of command script, takes that, connects to a data store, or connects to your source code repo to grab the analysis reports, the code coverage reports, and then push them up to Codecov to give you some kind of fancy report. Now, if you are affected, you would probably see in your GitLab, if you're using GitLab or GitHub, you would see a code coverage report that looks similar to this. You could also see it inline within your individual scripts. That's for GitLab, and then GitHub looks like this. Here's like an inline code coverage report. The official definition of code coverage, for those people who aren't familiar with it, is it's software testing metric that determines the number of lines of code that is successfully validated under a test procedure, which in turn helps in analyzing how comprehensively a software is verified. So you want to make sure that you run unit tests. You're doing all of this testing on your code to validating that the code is functional and meets the requirements of whatever software you're developing. That can generate reports on how much you've actually tested, and that report information would be grabbed by this Bash Uploader tool and siphoned it or passed into Codecov. So how did the hackers do it? As I said before, unauthorized access to a Google cloud storage key, then an exploit within the Docker image creation. The official statement from Codecov is, it appears that there was periodic unauthorized access to a Google cloud storage key beginning January 31st, 2021, which allowed a malicious third party to alter a version of our Bash Uploader script to potentially export information subject to continuous integration to a third-party server. The attackers exploited a bug in the company's Docker image creation process to gain access to a Bash Uploader script designed to map out development environments and report back to the company. This small modification quietly called out for user credentials that could have been used to access and exfiltrate data from their users' continuous integration environment. So, in a note posted on the Codecov website, CEO Gerard Engelberg said that any credentials, authentication tokens, or keys that were run through an affected customer CI process were exposed, and with them the attacker would have had access. Now this is important. They would have access to any corresponding services, data stores, application code, and Git repositories that could be accessed by those credentials. Why is that important? It's important because just yesterday, just on the 20th of April, in an article on VentureBeat, it says Codecov hackers gained access to hundreds of restricted customer networks. So that means that with the credentials and the keys that these hackers were able to access, it gave them, or able to grab, it gave them access to hundreds of clients internal networks. Hackers who tampered with the software development tool from a company called Codecov used that program to gain restricted access to hundreds of networks belonging to the San Francisco firm's customers, investigators told Reuters. So, you're now talking about hundreds of clients that have been affected. Not only have they been affected, their keys and their tokens and their credentials have been stolen and have been used to access their internal networks. So the hackers got inside their internal networks. So just to understand the process of how this could potentially happen, I just want to go through a quick diagram here. Call it the process. How does a code get tampered with, and at what point? Well, there are hundreds, if not thousands, of points that could happen depending on what your delivery chain is. One of the simplest delivery chains is here, your source code. You develop your source code, you keep it under strict lock and key, you generate a checksum. You then want to distribute your source code, whether it's from your website as a zip file or an NPM package, or whether it's on a GitHub as a repo, GitLab, Bitbucket, all of these repository systems. You upload it there, you provide the checksum. The developer, somebody who wants to use it, a developer, downloads that, runs a checksum to say, is the code that I just downloaded identical to the code that the developer originally provided for me? If not, somewhere in this very simplified delivery chain, a change happened, an unauthorized, you could say, change happened. Now it could be a mistake. I, as the developer of the source code, could potentially upload a change and not swap out the checksum. That's possible, but with that mistake and the developer following the correct process of doing a checksum when he downloads open source or any software that provides a checksum, he would be able to see that, alert me, we'd be able to verify whether or not it was a mistake on my part or whether or not somewhere along the lines a change happened. Now a hack could happen internally in my organization, somehow before the final submission to my repo or my website for the download. An injection could happen into the software. It could happen where the credentials or the keys or something to my Git repository were somehow left open or in the source code, and somebody gained access to my repository and made modifications directly in the repo, or gained access to my server, downloaded the zip file, modified it, re-uploaded it, and let somebody try to download it. It could also happen that on the person who's downloading it, their computer injects some code in some way, shape, or form to modify whatever application it is. It happens to be that I'm providing. So that's a very simplified. Again, you can have extremely complicated delivery chains. You can have very simplified delivery chains, but those are in essence the areas where these injections and these hacks can happen. So the key here for me is really the time span between when the hack started and when it was found. And I'll tell you why. January 31st is where they found, so far, the first hack, the first attempt, the first unauthorized use of the Google Cloud storage key. Right? This is the first time they saw that so far. April 1st is when a client downloaded a copy and did a checksum. So that's 2 months. 2 months that this hack went undetected. That's 2 months for the hacker to potentially be gathering information, grabbing your credentials, getting into your network, rooting around and doing whatever they want within your network without you knowing about it. Right? So why did it take 2 months for somebody to do a checksum? I see three immediate possibilities. First possibility is it's not a really widely used software. It's not like an app that gets downloaded 1 million times a week. If that's the case, and you have a restricted amount of customers, then you could, it's not always updated. You could see that every month or two or a few weeks, a new download would happen, and then people would be doing a checksum. It's a valid reason. The second kind of builds off of that, where yes, okay, there's hundreds of customers, as we just saw from the VentureBeat article that have been affected. There are hundreds of companies that are using this tool, but it's a single purpose application. It only has one purpose. Goes there, grabs the information, and brings it over to Codecov. It's not like a very complex software that has 50 different things and potentially could require constant update. So if I already have the software and an update only comes every few months, then there could be a few months span of time before somebody downloads a new version and realizes that there's a discrepancy there. The third potential reason is what I find troubling. The third potential reason is people are downloading it all the time, it's uploaded regularly, and nobody's doing a checksum. And after 2 months, the first diligent person who's doing the processes, performing the processes correctly, finally does a checksum, sees it. But all the other people who've been downloading this blindly and using it blindly without doing the checksum have put themselves in danger. So that is the main thing that you should be doing is checking your processes to make sure that when you're using third-party software that you are doing the simple task of performing a checksum to verify that the code and the application you're downloading is what the original developer intended you to have and not some modified version by somebody else. So I found something on Y Combinator about this, which I found to epitomize this issue of the processes. And it's a user called Nexus, and he says, of all the people in tech that I know, as friends or professionals, I know of exactly one guy who's diligent about comparing checksums, and it's the same guy with a multi-$1,000 home lab. Absolutely nobody's doing this frequently unless they've automated it or they have an obsession with privacy. Now, I have an obsession with privacy. Everywhere I work, every client I work, we're security. I'm a security first proponent, and with that, these small steps, regardless of how low the budget is, regardless of how limited time you have to find a way to implement these kinds of things, these very basic kinds of things within your processes. So we know what it is, we know how it was found, we know how long it's been there, we now know whether or not you have this. What do? The first thing you do is change your credentials in your CI process. This is exactly what the CEO Engelberg said. We strongly recommend affected users immediately re-roll all of their credentials, tokens, or keys located in the environment variables in their CI processes that used one of Codecov's Bash uploaders, Engelberg advised. I go one step further than that, though. Given the new information, given the update that hundreds of companies' internal networks have been breached, you need to go through your entire network. You need to shore up everything. You need to review all your processes. You need to change every token. You need to re-roll everything, all credentials within your infrastructure, and do a clean sanity check to make sure that nobody's in there. And see if somebody's in there. What did they do? What did they get? The second thing I see is, ignorance is not innocence. And it isn't. Just because you don't know something doesn't mean that you're innocent. So if you look at the processes and the automation, they are lifesavers. It's the only way we can survive within this industry is if we find ways to become more efficient, and it usually involves automation. But that doesn't mean that our processes, once implemented, are static. They don't stay that way forever. You have to set up at least biannually reviews of your processes for all of your projects, whether you're an agency or a major corporation or a startup. You have to re-review your processes and make sure they are up to date. Things change. Frameworks change. One week you're allowed to use React, the next week you're not allowed to use it. You got to swap it out. Well, with that swap out, you have to look at the process. You have to say, what were we doing when we integrated and downloaded new NPMs, when we integrated new libraries, frameworks. How do we do that? How do we strip that out? How do we take that out of our process with the automation process? And what are we replacing it with? And what do we need to do to keep that same level of security with this new thing? That's what you have to do. The third, and this might be the most difficult, is to integrate new processes. So, given the speed at which everything is changing, new things are coming out, everything is advancing, given the speed at which that's happening, you have to look at the process that you should have in place, and you have to change them and make them better. You have to add new things. And one of the things that Codecov has implemented, they say that they have this. It's part of their the way they work, is that no developer is allowed to freely use any third-party software. It goes through a vetting process. Let's say I want to use a specific package. I have to go to a secondary person, my third and fourth my second pair of eyes, and they vet that framework, they vet that library, they vet that for me to make sure that it meets the security requirements that we have in place, or that you have in place, before you're allowed to integrate that into any application that you're using. These are the things that you need to do in order to shore up your systems, shore up your all of your projects. Again, whether you're an agency, whether you're a Fortune 500 company, whether you're a startup, without this kind of attention to detail and these small things that need to be done, regardless of how much time or how inefficient sometimes they may seem like they are. If that's not in place, you run the risk of having this happen to you. So, I hope you enjoyed the video. I hope you learned something. Like I said, this is an evolving story. As more information comes out, I'm going to be making updates, maybe not to this video, but creating new videos that give you more details and more insights on things that things have been found out about, the things that I've learned about it, and potentially more ways for you to better improve your processes, your security, and be able to sleep well at night. So, if you liked the video, please give a thumbs up. Subscribe to my channel. I'll be putting up more videos about all different types of topics regarding IT, regarding DevOps, regarding security, regarding flow and processes to make you work efficiently, but maintain that eye on security first. Thank you very much. See you soon.